Well, a warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready. Grab a notebook, a pencil, or a pen. Whatever you choose to write with is fine. This is math for the void. Math coming at you pretty much out of nowhere. And today we have a couple of tender trig equations. This is going to be very important for you calculus students, AP Calc students. This isn't calculus, it's trigonometry. You recognize this, of course. But you're going to need to solve trig equations like this from time to time, depending on what types of functions we're using. So be prepared. This is one of your last chances to get prepared before you really start using these skills. If you're in trigonometry or pre-calculus or math analysis or whatever they call it, integrated math 3 or whatever they call it, you'll be needing this skill at some point. It might be a little far from you for now, though. This may or may not be for you if you've already learned the nature of the unit circle. Otherwise, trigonometry awaits you. So for those of you who can solve this, go ahead and pause the video, give yourself about 10 minutes or so to try to figure these out. And these are some really tender equations in that you need to be careful in precisely how you simplify your equations. You don't want to go canceling solutions now, do you? I've said too much already. After you've given it a shot, when you're ready, you can unpause the video. Come on back, see how we did it here. Okay, first thing I'm going to do, as I often do, is give myself some space. Both of these equations need to be solved on the interval from 0 to 2 pi. This is just sort of like our unit circle, right, from 0 to 2 pi. And this does require you to use a double angle formula. See if you can recall the double angle formula. For sine, you will not have to memorize the double angle formula all that much. I just like to throw it in there. It will make your life easier if you know the double angle formula. It's not required necessarily. So the double angle formula for sine of 2x is simply 2 sine of x cosine x cosine x. Now it's very tempting to want to cancel this by dividing cosine on both sides. It's very tempting to do that. You should not do that, because you'll be eliminating solutions from your equation. Instead, when we get a situation like this, you should take a mental note that instead we're going to want to move things over. We're going to subtract cos x from both sides. That's going to leave us with a better equation, which says 2 sine cos x, 2 sine x cos x minus cos x equals 0. Why is this better, you might ask? Because rather than canceling the common factor on both sides, we can move everything over and factor it out. So we take the cos x out, and now we're left with 2 sine x minus 1 equals 0. Great. Now we can exploit the beautiful zero product property. It's an absolutely phenomenal property that allows us to say, well, cosine x could equal 0. Let's solve that, see what would happen. Or this other factor, 2 times sine x minus 1, could equal 0. And it takes a little work. We need to add 1 on both sides. We need to divide 2 on both sides. But eventually, you'll get that sine x equals 1/2. And now this is time for us to use our unit circle knowledge. You've got to ask yourself, where on the unit circle, in other words, what angle, has a cosine value of 0? Well, we just kind of sketched out the unit circle. We know that cosine is the x value of any point on the unit circle. So that's going to be at this angle up here and this angle down here. We call this angle pi over 2. And we call this angle 3 pi over 2. So those are two solutions that we would have completely missed if we had simply canceled cosine x on both sides. Okay, on the other hand, it's possible that sine of x equals 1/2. And if we draw a little unit circle, remember that sine is the y-coordinate. So we're looking here and here, where the y-coordinate is 1/2. What angles are those? Since we're limited to the unit circle from 0 to 2 pi, only one wrap around the unit circle, we're going to have x is pi over 6, or of course we have 5 pi over 6. It's also valid. Those are our two angles for each factor. So overall, you could plug any of these numbers in, and I encourage you to do that, to check these. It's also a great way for you to practice your trig. I know that doesn't sound fun. I know it doesn't sound inviting, but really, check it. Use the pi over 2, for example. Sine of 2x equals cosine of x. It doesn't take that long to do it, guys, and it's really worth checking, because I always nag to my students about reviewing the unit circle. But if you just solved a couple equations like this, that's plenty of unit circle review. Just solve a different one each time, so you're not doing the exact same angles. But this works, right? Because sine of pi is 0, cos pi of 2 is 0. And then we can maybe check one of these weird ones like pi over 6. So let's say sine of 2 times pi over 6. That should equals cosine of pi over 6. So this is basically sine of 2 pi over 6, which we call pi over 3. And we're saying this is equal to cosine of pi over 6. Well, that's true. Sine of pi over 3, rad 3 over 2. Cosine of pi over 6, rad 3 over 2. See how you get to practice your unit circle just by checking your work. And you can check the other two if you'd like to. Now let's move on to the next equation. Sine of x equals tan of x, which could really be rewritten as sine of x equals sine of x over cosine of x. Or if we multiply it on both sides by cosine of x to kind of bust the fraction, get rid of the denominator, we would get that sine x times cos x equals sine x. And again, we have that risky opportunity to cancel and ruin our final answer. Don't ruin your final answer. Don't remove possible solutions. Why would you do that in life or otherwise? Don't remove possible solutions. Instead, move everything over on one side, and we still maintain the balance. This is all equals to 0, but the benefit is that we can now factor the sine x out. So don't just cancel the sine of x out. Move it aside and let it be special on its own. If we take the sine out, of course, that leaves us with cosine here, and that sort of just leaves us with a 1, a minus 1. We get to exploit this beautiful property called the zero product property. We have sine of x could equal 0, or cosine of x minus 1 could equal 0, which really just means cosine of x equals 1. And again, we're going to check for angles on the unit circle where this happens. Now, when is sine 0? If we look at the unit circle, since sine is the y value, it's 0 whenever the y value is literally 0. So we call 0 and pi, but not 2 pi. Why not? Because I excluded 2 pi. You see this, not a bracket. This is a parentheses. So we're not including 2 pi, even though it is true that sine of 2 pi is equal to 0. It's not going to be a solution angle. And cosine x equals 1, that's the x value. It's only positive 1 here. It is negative 1 at the angle of pi, but we want cos x to be positive 1. So we're only looking at this angle, which is 0, not 2 pi. Even though cosine of 2 pi is 1, it is not on our interval. It is not in your domain. So the only x solutions here are 0 and pi. And you can try them out for yourself. Sine of 0 equals tan of 0. Sine of pi equals tan of pi. Okay, so if you can solve those basic trig equations, you'll be in pretty good shape for the trig required in calculus, to be honest. There's a little bit more you need to know, but you can always practice your unit circle by solving trig equations. As far as identities go, we didn't really exploit too many identities. We have the double angle formula here. You shouldn't expect to memorize this. Some harder classes will have you memorize it for maybe one test, but my AP Calculus students definitely don't need that. Okay, I think that's enough blab out of me. I'll see you guys next time.